Hello students, good evening all, welcome to the session. Today we'll discuss about circle's equation, the equation of circle in coordinate geometry and its different forms, like various forms, and how we find the equation and how we find the radius of the circle, and how to find, like, if you have two circles, and how to find its common chord. So we'll discuss about all of these concepts in this session. First, let us discuss about the general form of a circle. Say if the circle has a center at h comma k. So this is the center of the circle given to us, and say the radius of the circle is a. If a is the radius of the circle and say the center of the circle is at h comma k, then what would be the equation of the circle? So the equation of the circle is given by x minus h whole square plus y minus k whole square is equal to a square. You all know, right? Like if there is a circle and say the center is at h comma k, and say you take a point on the circle, any random point on the circle, say x comma y, and now we know that the distance from this point to the center is the radius, and now we know the formula of the distance, right? Like what is the formula of the distance? Root of x2 minus x1 whole square plus y2 minus y1 whole square is the distance. So using that, we can simply write x minus h whole square plus y minus k whole square is equal to a, or say here let us call the radius as a. So this will be equal to a, as we took the radius as a here, right? Now if you square this on both sides, you are getting your equation of the circle like this, like which is x minus h whole square plus y minus k whole square is equal to a square, a being the radius. This is the equation of a circle when the center and the radius is given to us, right? Now what if the center of the circle is at the origin? Say center is 0 comma 0. This is the center of the circle, and say the radius is again, say a is the radius. So what would be the equation? So when you have a circle and the center is at 0 comma 0, and again if you take the same just like the previous case, if you take x comma y as the points on the circle, as a point on the circle, then the radius square will be equal to the square of the distance between those 2 points, which would be x minus 0 whole square plus y minus 0 whole square, which would be equal to a square. So simply we can say x square plus y square is equal to a square is the equation of the circle when it is passing through the center, right? Now let us talk about a peculiar case where the circle's center is at h comma k and it is passing through the origin. Say the circle is having a center at h comma k and it passes through 0 comma 0. There are other points, right? Not only 0 comma 0, there are so many other points. So x comma y and x1 comma y1, and you can say p comma t comma s, whatever you take. These different points are there on the circle. There are so many other points, not only these 4 which I have written here. There can be different points. In that, we are taking a particular point which is 0 comma 0 is a point on the circle. So this is a special case. When 0 comma 0 is a point on the circle, then it has a special equation. So let us try to find that out. Okay, now what is the general form of the equation we just discussed? X minus h whole square plus y minus k whole square is equal to the radius square. Let us say the radius here is r. We don't know the value of radius. Okay, so we will find out the radius and get the equation of the circle here, right? Now this is the equation of the circle for me. Now what can I do? I have a point 0 comma 0 on the circle, right? So I can substitute the value 0 in the place of x, at the same time 0 in the place of y. So what do we get? Like 0 minus h whole square plus 0 minus k whole square will be equal to the radius square. In other words, h square plus k square is simply the square of the radius, right? So now what would be our equation now? So x minus h whole square plus y minus k whole square will be equal to the radius square, which is nothing but h square plus k square. Is that clear? Now see, suppose if I want to further if I want to simplify this, I can expand and simplify, so you get h square and k square on your left hand side, which are same as h square and k square on the right hand side. You can cancel them, so you would be getting x square minus 2hx plus h square plus y square plus k square minus 2ky, which will be equal to h square plus k square. And now I can remove this I can remove this h square k square and h square k square here. This is still there, this y square is still there, right? Now what is our equation? X square minus 2hx plus y square minus 2ky is equal to 0 is the special equation of this circle. So when a circle is passing through a particular point, a special point, which is here our origin, like 0, 0, then the circle has an equation x square minus 2hx plus y square minus 2ky, h comma k being the center of the circle and r being the radius. Like we have calculated the radius r of the circle, right, in terms of h and k, and then this will be our special equation of the circle when it is passing through the origin. That is clear, right? So now let us talk about the equation of a circle which has the center at h comma k, but the circle is touching the x-axis. Say I have a circle which has a center h comma k, right? And now this is touching the x-axis. It is touching the x-axis. Then what would be the equation of this circle? So this is a special case again. Like we have different cases, like you can find different equations for the circle in different cases. So we are discussing all of them one by one. So now here we are discussing about the equation of a circle which is touching the x-axis. So say h comma k is the center, right? So if you join a line from y-axis perpendicular to y-axis to the center, you get the y-intercept, which is nothing but k here. So the point here will be 0 comma k, right? So what does this give us now? Like the radius of the circle, in other words, the radius of the circle will be equal to the y-intercept, which is k, right? So the radius of this circle here is k. Now what will be our equation now? What is the equation? X minus h whole square plus y minus k whole square is equal to r square, where r is the radius, right? But what is the radius here? The radius here is k. So you can substitute k in that place. So x minus h whole square plus y minus k whole square will be equal to k square is the equation of the circle when it touches the x-axis, right? So now can you guess like what would be the equation if the circle touches y-axis, right? So let us look into that as well. Like see, if I have a circle, say the center is again like h comma k, which is touching the y-axis. This time it's touching the y-axis. Now the radius here will be nothing but the x coordinate, which is h, right? So simply you can say x minus h whole square plus y minus k whole square is equal to h square is the equation of the circle. right? So now we have discussed about the equation of a circle when a center is given and when radius is given and when it is passing through the origin, when it is having origin as its center, and when it is touching x-axis, when it is touching y-axis. Now what if the circle touches both the axes? Say suppose the circle, let me draw it here, is touching both the axes, okay, touching the two axes, say x-axis and y-axis. This would be the center. Say now this is the radius here, so this also would be the radius, right? Can you guess what would be the center of the circle here? Yeah, since this is the radius, these two are the radii, this length and this length should be same, so this should be either h comma h if you take, or else say it can be k comma k or whatever it is. So it should be the same point, like x and y coordinates should be the same, right? Now the equation would be x minus h whole square plus y minus h whole square would be equal to h square is the equation. Here the center is h comma h and the radius is also h. This is another case of equation of the circle when it is touching the axis. So now you have seen the equation of the circle when it touches x-axis, when it touches y-axis, and when it touches both the axes, right? Good. Now let us see the general form of the equation of a circle. What's the general form of the equation of a circle? We all know, right? Like x square plus y square plus 2gx plus say 2hy plus c is equal to 0, right? Now how can we find out the radius from this one? Like if I want to find the radius of the circle, now this is an equation given to us. Say suppose a random equation is given to us, say x square plus y square plus say some 6x plus 5y plus some 8 or something is given, and they ask us to find the radius, identify the radius of the circle. So for that, like how do we find the radius of the circle when an equation this way is given? Like it is not given in the standard form. See, if an equation is given in the form like x minus h whole square plus y minus k whole square is equal to say some s square or something is given, then we can simply say that h comma k is the center and s is the radius, right? S is the radius. This is what we can easily say, but this is not in that form. So how do we find the radius and how do we find the center of the circle here? So let us take the concept, like I think you all might know about completing squares. So we'll complete the squares in the variable x and in the variable y respectively, and you will simply get your equation into this standard form. So let me do that for you now. So x square plus 2gx. So I have the 2ab term here. So what else do I need now? Like I need the b square term, which is nothing but g square. And then I have y square plus 2hy. Here also I have the 2ab term. Now I need the term b square, which is nothing but here h square is equal to minus c. So I'm just pushing c to the other side so that I can simply have x minus h whole square plus y minus k whole square form, right? So now if you look at this one here and this one here, these are in the form of a plus b whole square. So this is can be written as x plus g whole square plus this can be written as y plus h whole square, which is equal to minus c. Right now, if you look at this carefully, we have added g square and h square on the left hand side of the equation without caring what is there on the right hand side, right? So will this equation still hold true if I simply add the terms whatever I like on left hand side, or maybe say right hand side? No. So what we have to do to balance the equation, to make the equation still hold good, you have to add the g square and h square on the right hand side as well, right? So you have to add it on the right hand side. So I here have g square and h square, Right. Now this is the now if you look at this carefully, if you can compare this with x minus h whole square plus y minus k whole square is equal to r square, here I will have this as my radius. So the radius would be equal to square root of h square plus g square minus c. Right. And the center of this circle is minus g comma minus h, because it is in the form of x minus of minus g whole square plus y minus of minus h whole square, where h and k, if you compare with this equation, the given standard equation of the circle, you will easily understand that the value of the center here is minus g and minus h. Right. So when an equation of the circle x square plus y square plus 2gx plus 2hy plus c is equal to 0 is given, the center is minus g comma minus h, and the radius r is given by root of g square plus h square minus c. This is the radius when an equation is given this way. So generally, say suppose some equation is given to us, say x square plus y square minus 3x plus 2y plus 5 is equal to 0 is given, and they ask us to find the radius of the circle. So what can you do? The radius is nothing but g square. What is g here? Minus 3. So minus 3 square is 9, and h square, which is 2 square, which is 4, and then you have to subtract c, which is 5. This will give you the equation, the value of the radius of a circle from this type of equation, which is not in the standard form. Right. Now we have seen that when the circle is on the x-axis, maybe even like touching x-axis or touching y-axis, or if it is touching both the axes. So these are the cases we have seen. Now what if the circle is cutting an axis? Say it is cutting the x-axis here, right? It is cutting the x-axis. Now they say this point is, say, some x1 and this point is x2. What if I want to find the length of the intercepts made, means the length of the chord? In other words, like if I want to find the length of this chord when it is cutting the x-axis, how can I find it? And say the equation of the circle is given as x square plus y square plus 2gx plus 2fy plus c is equal to 0 is the equation given to us. Right. Now if you look at this carefully, I have the points x1 and x2 on the x-axis. That means that points, 2 points I have are x1 comma 0 and x2 comma 0. Right. So now if I substitute these values in that, like these 2 points are on the circle, right? That means these 2 points should satisfy the equation of the circle. That means what? If I substitute these in there, so I get x1 square plus the value of y will be equal to 0 plus 2gx1 plus 2fy value is 0, so that will entirely become 0 plus c is equal to 0. Right. So I got a quadratic equation in one variable now. You understood, right? Like if I am substituting, so these are the I get two equations. This is my equation 1, you say, when I am substituting the first point, right? x1 comma 0 is a point on the circle. So if this is a point on this circle, it should satisfy the equation of the circle. That means I can remove the y, the terms with the variable y, because y is becoming 0 here for me. Then x1 square plus 2gx1 plus c should be equal to 0. This is a quadratic in terms of x1. Similarly, you get when you substitute x2 square plus 2gx2 plus c is equal to 0 as your second equation when you substitute this in there. Right. Now what can we say from this one? Like if we look at this, these two equations, these are the quadratic equations in terms of x1 and x2, right? Now if we add these two equations, just give me a second, students. Yeah, see, now this is a quadratic equation. If you look at this, the values, like, you know, the what we call the roots of the equation. See, now these two are the roots of my equation, right? So what is the equation for me now? X square. See, these are the values I substituted. These are the roots I substituted in the quadratic equation. Now what is the quadratic equation? The general form of the quadratic equation is 2gx plus c is equal to 0 is the general form of the quadratic equation, right? And x1 comma x2, these two are the roots of this equation. Correct. Now sum of the roots of a quadratic equation is what? Like, sum of the roots is here x1 plus x2. Am I right? Now this should be equal to the coefficient of b and a minus b by a, which is here minus 2g, right, by 1, which is minus 2g. Similarly, the product of the roots x1 and x2 is equal to c, right? These are the two equations which I derived from the two roots which are given to me, like x1 and x2 are the roots of this quadratic equation, right? So now if we substitute, if we try to find, like, what are we trying to find? We are trying to find the length of this chord, means the distance from here to here, right, which is nothing but x2 minus x1, which is the length of the chord, right? So how can I find length of this chord? Now you all might know this formula, right? Like a plus b whole square minus 4ab is equal to a minus b whole square, right? So now I want x2 minus x1. So from this I can say a minus b is nothing but root of a plus b whole square minus 4ab, which I'm going to substitute here. X2 minus x1 will be equal to root of x1 plus x2 whole square minus 4ab, which is nothing but 4c. So this is nothing but square root of minus 2g whole square minus 4c, which is root of I can take 4 common out, which becomes 2 times g square minus c. This is the length of the chord when a circle cuts the x-axis. Is this clear? So in general, we can also say that the length of the chord is nothing but 2 times root of r square minus p square. What is p? What is r? See, suppose I take a perpendicular from the center to the chord. This length is called as p, and this is called as the radius. So this is the general formula to find the length of a chord when a circle is when a circle has a chord inside it, right? Now let us discuss about the parametric equations of a circle. Say, suppose the equation of the circle we have is x square plus y square is equal to a square. This is the given equation of the circle, right? So if I have to find the parametric equation for this, like what is the parametric form of this equation? So what should I take? I should take x is equal to a cos theta and y is equal to a sin theta. So this will help me in getting to that, right? Like if you substitute this into the equation here, you get a square cos square theta plus a square sin square theta, which is equal to a square, right? It satisfies these 2 points, satisfy this, right? Suppose the equation given to us is x minus h whole square plus y minus k whole square is equal to r square. Then what is the parametric form of this equation? Then it is simple, like x minus h is equal to r cos theta and y minus k is equal to r sin theta. These are the parametric equations of the circle, right? So far we have discussed about the equations of circle in various forms, and we found out the length of the chord when the circle has a coordinate, and we found out the equation of the circle when it is touching the axis. We found the radius when general form is given. Now we will discuss about the various conditions of circles. Like if there are two circles, like how can two circles be? They can touch each other externally, they can touch each other internally, they can cut each other, they can they can be away from each other like without touching externally and internally, right? So these cases may, like what would be the cases, like what is the relation between their radii, or what is the relation between their centers, means the distance between the centers and the radii, how they are related. Let us have a look at them now. So suppose I have a circle with center C1 and say a radius R1, and I have a smaller circle say of radius R2 and say the center C2. Now it is evident, right, like since these are touching, the radii 1 and radii 2 will add up to give us the distance between the centers, right? So what if they touch internally? Suppose these are the two circles which are like this, touching each other internally. So they say this is the center here, this is the center R1, and this radius, let us take this as R2, and the first radius as R1, center 1 and center 2. So what would be the distance between these two centers, right? Like the center's distance is R1 minus R2 will give us the distance. So it is R1 minus R2. This is when the two circles are touching each other internally. And say suppose if the circles are intersecting each other, say this is the center 1 and this is the center 2, and these are intersecting, and up to here say the radius is R1, and up to here you say the radius is R2. Then what would be the distance? Like C1, C2, the distance will definitely be less than R1 plus R2. And also C1, C2 will be definitely greater than R1 minus R2. The distance between the two centers will be greater than the difference of the two radii and will be less than the sum of the two radii, right? And then there is a case where the two circles don't intersect each other. Say these are the two circles which are away from each other. Say this is C2 and this is C1. We are taking, because the bigger circle always we are taking as the with center 1 and the radius 1, right? So I named them like this. Now this radius is R1 and say this radius is R2. Now what is the distance between the centers? So C1, C2 is greater than R1 plus R2, right? Now the last case, when the two circles are lying inside each other, say with the centers C1 and C2, and say this is the radius R2 and this is the radius R1, right? This is the radius R2 and this is the radius R1. Now what would be the distance between C1 and C2? This distance will be less than R1 minus R2. If you subtract the smaller radius from the bigger radius, that value will still be less than, will be lesser, greater than the distance between the two centers, right? Now, so we have seen a case where the two circles intersect each other, right? There are two circles which intersect each other. Say suppose these are the two circles which are intersecting each other. Say this is with center C1 and this is with center C2. These are the two circles which are intersecting. Now these two have a common chord. These have a common chord. So what would be the equation of this common chord? So name this circle as S1 and so name this circle as S2. What would be the equation of this common chord? How do we find the equation of the common chord, and how do we find the length of the common chord? So I want to find this length. How can I find that length? we have seen when a circle intersects the axis, we found the length of the intercept, which is nothing but the length of the chord, right? So in the same way, like if you have two circles which are intersecting each other, then how do you find the length of the common chord? So now first what it is here is like you have to say, suppose this one is given as x square plus so 2gx plus 2fy plus y square plus c is equal to 0, and the other one is given as x square plus 2g1x plus 2f1y plus y square plus c1 is equal to 0. So these are the two equations given to us. Then if you find s1 minus s2, see these are the two equations. If I subtract, this is S1 equation, circle S1, and this is circle S2. So what will happen if I find the difference? The difference will still be 0, right? Since these two values are equal to 0, the difference between two zeros are again 0, so this will be equal to 0. But if you observe carefully, I have put the coefficients of this x square and y square equal, like say precisely make them unitary coefficients, like their coefficient should be equal to 1. So when you subtract this, what are you going to get? Your second order terms are getting nullified, right? Like you don't have any x square term in it, or you don't have any y square term in this, so you'll simply have a linear form. So you got a linear equation or a linear expression. Yeah, it is an equation since it is equal to 0, a linear equation which satisfies both the equations of the circle. That is nothing but, it is nothing but the equation of a line which is connecting the 2 points on the circle, which is nothing but our common chord here. Right? So when you have two equations of means two circles with different equations, make their coefficients of the x square y square terms equal, and then subtract them, you simply get the equation of the chord. Right? You understand? Now the length of the chord we already have discussed, right? Like it is nothing but root of 2 times root of the radius square minus the length of the perpendicular from the center to the chord square. If you do this, you will get the length of the chord, right? This one we already discussed earlier, right? So now you understood like how we got the length of the equation of the chord, correct? Now here if you observe carefully, say here the distance p is equal to the radius. Distance p is equal to radius. What happens? What is it? Say suppose I have a chord here, I have a chord, and this is the length p, and this is the radius r. Now the radius and the distance of the chord from the center is equal. That means it is this chord is just touching the circle, right? So that means if radius and the length of the chord, the length of the perpendicular from the center to the chord are equal, then it becomes a tangent. It is a tangent. It's not a chord, it's a tangent now. So now the remaining cases are easily understood, right? Like that means when will it be a chord? Yes, if the distance is less than radius, p is less than r, then it is a chord, and if p is equal to r, it is radius, and if p is greater than r, then it is simply a line which has no relation to the given circle, right? So now let us quickly solve some problems on the concepts we have just learned from our previous papers. So the first question here is the equation of circle with center 1, -3 and touching the line 2x minus y minus 4 equals to 0. I think we just discussed about this one, right? Say there is a circle whose center is at 1, -3. And it is touching a line, so let me draw the line this way, and it is touching a line 2x minus y minus 4 equals to 0, right? Now can we calculate this distance here from center to this point, right? This is P, which is nothing but our radius also, as this is a tangent, correct? This is a tangent to us, right? Now how can I calculate the distance between a point and a line? How do I calculate this? Suppose I have a point P x1 y1, and I have an equation ax plus by plus c is equal to 0. Now I want to find the distance between these two. We know the formula, right? The distance is given by modulus of ax1 plus by1 plus c by root of a square plus b square, right? So now I can find the radius of the circle using this, right? If I know the radius of the circle, then it is simply, it's very easy, right? Then like you can write the equation of the circle in the standard form, like x minus h whole square plus y minus k whole square is equal to r square, right? So now let us find the distance, which is our radius here. So the radius will be equal to modulus of a, here in our case a is 2 times x1 is 1 and minus b here is 1 times y is minus 3 and plus c is minus 4 here by root of a square plus b square, which is 2 square plus 1 square. So the radius here is equal to 2 plus 3 minus 4 by root of 5, right? So this is equal to 1 by root 5. Now equation of the circle. What is it? X minus h whole square plus y minus k whole square is equal to the radius square, which is x minus, here h is nothing but the x coordinate of the center, which is 1 whole square plus y plus 3 whole square, as here k is minus 3, which is equal to r square, which is equal to 1 by 5. This is the equation which we have to find out. Is that clear? Now the second question, the equation of circle passing through 4 comma 5 and has a center 2 comma 2. See, he gave a circle, right, whose center is 2 comma 2, and he says that it is passing through a point 4 comma 5, and we just need to find the equation of this circle. I'm sure like most of you might already have solved it, because it's a very pretty easy sum. You can just find the radius by using the distance between these two points, right? So here the radius would be equal to square root of 4 minus 2 whole square plus 5 minus 2 whole square. So the radius is nothing but 4 plus 9, the radius is root 13, right? So once we have the radius and the center, the answer is very simple. It is x minus h whole square plus y minus k whole square, which is equal to the radius square, is the equation of the circle. So here x minus, the center is 2 square plus y minus 2 square is equal to 13, is the equation of the circle which we are trying to find out, right? Next, the third question is two straight lines, 3x minus 2y minus 8 equals to 0 and 2x minus y minus 5 equals to 0 lie along two diameters of a circle. So these are the two diameters, like these two lines are the secants which are passing through the center of the circle, right? Like diameters means what? It passes through the center. find the equation of the circle if the circle touches x-axis. So when the circle is touching x-axis, so you have to find its equation now. So given information is like two of those lines which are the diameters, like which lie along the diameter. So say suppose this is the circle and this is the center. So this is one diameter, say given to us, 2x minus y minus 5 equals to 0, and say so another diameter, say this is the center now, and this equation is given by 3x minus 2y minus 8 equals to 0, right? These are the two equations given to us. So how can we find this now? If you observe carefully, like if you look into it a bit carefully, you will know that these two are the diameters, like these two line segments. If you take them as the line segments, they are the diameters. They intersect at the center. That means if we solve these two equations as simultaneous equations, you get the center of the circle, right? So let us quickly find out the center first. 2x minus y minus 5 equals to 0, and 3x minus 2y minus 8 equals to 0. So let us multiply this with 2, then we get 4x minus 2y equals to say 10, and 3x minus 2y equals to 8. So on solving this, we get x equals to 2, right? Now you can find the value of y from this very easily, like y is equal to 2x minus 5, so y equals to minus 1. So now I have the center, the coordinates of the center, which is 2 comma minus 1, right? So with the center, I just have a center now, right? So with the center, can we find the equation of the circle? No, right? But we have one more information given to us, that it is touching the x-axis. What is it doing? It is touching the x-axis. So we already know when it touches x-axis, the radius is nothing but the y coordinate, right? We have discussed that, like when it is touching the x-axis, the radius would be nothing but the y coordinate. So here the radius of the circle is equal to minus 1. So when the radius is minus 1 and the circle center is known, then the formula is very simple, straightforward, like x minus h whole square plus y minus k whole square is equal to r square. So here x minus 2 whole square plus y plus 1 whole square is equal to 1. Minus 1 square is 1 is the equation of the given circle, right? So when two lines are given, like see what is the main assumption we did here is, like when two lines are passing through the means are lying along the diameter, that means they are intersecting diameters, that means they intersect at the center, right? So using that if you don't hold that point, like if you don't find that point out, if you don't figure that point out by yourself, you will never be able to solve that. Understand? So what you have to do here is, like when two lines are intersecting and they are the diameters, that means they are passing through the center. So you know the center then. And then forget not that when it touches the x-axis, its y coordinate will be the radius. And say if it is touching the y-axis, then the x coordinate will be the radius. So using that, you can find the equation of the circle, right? And the fourth question is, the equation of a circle and a line are given to us here, right? See, the equation of the circle is given as x square plus y square minus, let me write the equation, if you can see or not, I'm not so sure, so I'm writing them a little big here. So the equation of the circle given is x square plus y square minus 8x plus 2y plus 12 equals to 0 is the given equation of the circle. Along with it, he gave us an equation of a line which is x minus 2y minus 1 is equal to 0. This is the information given to us, right? Determine if this line is a chord to the circle. So we have to check whether this is a chord to the circle. We already discussed, right, like when the radius is equal to the distance between the line and the center, then it is a tangent. If it is greater, then it is not a chord, it is neither a chord nor a tangent. And if it is less than, if the distance is less than the radius, then it is a chord. So now we have to find out whether the distance, say suppose this is the equation of the circle, This is the center. We don't know the center as well as of now, and we know a line. So I'm not drawing the line here because I'm not so sure whether it is inside the circle, outside the circle, or touching the circle. So I'm not drawing the circle for a line for now, but there is a line here. So we have to find the distance from here, whatever it touches the line, wherever it touches the line, you have to find the distance, and you should know the radius. Do we have the radius? No, right? So you have to find the radius also here. So for that, first what we will do, we can convert this into general form of the equation, or you can also use a formula which we have learned, right? Like, what is the radius formula? Do you remember? Which is nothing but g square plus h square minus c. I'm sure you might remember it. Like here the value of g is minus 8, h is 2, and c is 12. Using these three values you can find the radius, or else you can use the completing squares form and you can find the center, and then you can find the distance again. So here I'm trying to find the radius. But see, this way if I do, I get the radius, I'm happy with that. But I also need the center, right? I also need the center to find out the distance between the center and the line given to us, right? So for that, what I will do is I would prefer going by changing it into a standard form, right? You can use this one also, you can try by yourself, but I'm trying to change this into by using completing squares now. So x square minus 8x. 8x I'm writing it as 2 times 4 times x. So I need b square. The b value here is 4. So it should be b square is 4 square, which is 16. Plus y square plus 2y, and here b is 1. So b square is 1 plus or minus. Let us see now. See, here we have just 12 with us. But how much did we add so far? I have added 16 here, and I have added 1 here. So 1 plus 16 is 17 is added. How much is added? 17. But what do we have? 12. So the difference is how much? 5. So I just need to subtract 5 from this to keep the equation intact. Right. So now this entire thing can be written as x minus 4 whole square plus y plus 1 whole square is equal to 5. So here the radius is equal to 5 and the center is 4 comma minus 1. Let us verify, like if we get the radius say 5 or not by using this. If you want, we can just verify it, which is the radius is g square is how much here? 64 and plus 2 square is 4 minus 12 square is 12, right? So r is equal to root of 68 minus 12, which would be, so sorry, 2 times, right? Right. 2g square is needed. Yeah, we have to get into this 2g, right? Yeah, this is 2gx, this is 2hy, right? So yeah, that's the mistake we did. See, you have to be very careful when you are solving this sum. See, I got confused when solving this. Like I thought this is g, this is the term 2gx, and this is the term 2hy, right? So here the value of g will be equal to how much? So g is equal to just minus 4, and here the value of this will be 1. H is 1. So if you substitute those values, you will get the value of the radius as 5. You substitute and see, you will definitely get it. Okay. So be very careful. Like when you are doing this, you identify where your g is. Like you have to compare it with your 2gx and 2hy. That's the equation, right? Like x square plus y square plus 2gx plus 2hy plus c is equal to 0. This is the equation you are comparing with. Don't just get confused like how I did just now, right? Be very careful, like find out the value of g very carefully. So now I have the center and I have the radius, both the values I have, right? Now I can find the distance. Distance is what? We already have the formula ax plus by plus c by a square plus b square. So here A here is in this, A value is 1 times 4, and B value is minus 2 times minus 1, and C is minus 1 by root of A square plus B square, which is 1 plus 2 square is 4. So the value of D is 4 plus 2 is 6, 6 minus 1 is 5 by root 5, which is equal to root 5. Yeah, here this is the radius square. So the radius is root 5 here as well, right? The radius is root 5. This is in form of r square, correct? This is r square. So radius is root 5. Now what did we get? The radius of the circle and the distance of the center from the distance of the line from the center as root 5. These two are equal. Then what can we conclude? This line is a tangent to the circle. It is not a chord, it is not any other line, it is tangent to the circle. So you can simply say it is a tangent. I hope you understood what we have discussed so far. Let me see if you have any questions. I will quickly get to it. Just give me a second. Yeah, I have got a question from one of you saying that, like, what would be the formula to find out a point which intersects the circle internally and externally when you have a line joining 2 points, say x1 y1 and say x2 y2, and if it is intersecting it in the form in the ratio m is to n internally, then what is the formula for it is what I have got the question. So this formula is very straightforward. Say this, if I call this as x comma y, so x comma y is given by mx2 plus nx1 by m plus n, and my2 plus ny1 by m plus n is the formula when it is dividing internally. And if it is external, it would be like mx2 minus nx1 by m minus n, and my2 minus ny1 by m minus n. This is the external division. Like when a point is dividing the line joining 2 points externally in m to n ratio, then it would be this formula. I think I hope I have answered your doubt. So I hope you understood today's session, and I have enjoyed a lot teaching you guys. I hope you also have enjoyed. I'll catch you back again with one more interesting session. Till then, signing off, yours Satish from Toppr.